Boom! All right, folks, so we're back again. We're back now to work out multiplication using a pair of 2 by 2 matrices. Yes, the light is a little different because it has been a day of recording, and now more or less coming back in the night to finish the recording from this morning. Same series of videos on matrices. Yes, if you're seeing some fatigue in the face, that is also part of the equation. And if you're working hard enough, then at some point you have to deal with that. Fatigue, get your rest, right? Work hard by all means, but make sure and get your rest. No point overworking yourself, because we know it is, the human body will take over at some point, whether or not you want it to do that. So we know we try not to let it reach that point. Get your rest, and we go again. All right, so let us now do an example where we're multiplying a pair of 2 by 2 matrices. So again, A by B is equal to C. All right, so we pick a random matrix now. 3, 0, minus 4, 1. That's the matrix A. And the matrix B is 16 minus 2, 3, 7. All right? So again, just as we would have done earlier on with the matrices 1 by 2 and 2 by 1, 2 by 1, 1 by 2. All right? We have 2 by 2 multiplied by a 2 by 2. And we look at the number of row by column, number of columns in matrix A being equal to the number of rows in matrix B. So again, we circle that, and we know that the answer will be a 2 by 2 matrix. So again, I'll continue working out just for the sake of explanation. You know that the matrix will look something like this. Now, just to explain something here. Eventually, when you start to work out more of these things, it wouldn't be necessary to do this. All right, this is like when you're now learning to ride a bicycle and you have the little, I forget what they call them, little wheels on the outside to make sure the bike don't fall. And you ride and you ride and you ride, and eventually you don't need the wheels anymore, and you could go on 2 wheels. All right. So anytime we learning, and we now learning, we need a prop, like a baby learning to walk. Right? It hold on and it lean and it stuff, fall on a little bit and it get up and it go again. So that is the same idea, that is the same philosophy that I try to apply when teaching stuff. We're teaching, assuming little knowledge, assuming little or no foreknowledge. Right? So if you're already familiar with this, or you're getting the sense of what's going on, then you wouldn't need to put this here. All you'll have to do is just go straight into the arithmetic, which we will do now. So again, just as we would have done prior, you have row 1, you have row 2, you have column 1, you have column 2 here. You have row 1 here, row 2 here, you have column 1 here and column 2 here. Alright? Yeah, don't mind the handwriting looking a little crazy sometimes. Just listen to what they're saying and you'll know exactly what it is I'm writing. Alright? Row 2. And by the same token, in the matrix C, this is row 1, this is row 2, this is column 1, and this is column 2. Beautiful. So again, we know what the answer looks like. It's now a question of filling in the blanks. I could stay with the black alone now. Right? Yeah, I had to don't hold more markers in the hand, and it's absolutely necessary. So again, this guy here will be formed. You're looking at it here. The location of this fellow here is at the intersection of row 1 and column 1 in the matrix C. Then what we do is we interact the whole of row 1 from the matrix A and the with the whole of column 1 from matrix B. Good? So when we do the arithmetic, we will get something of the order of, all right, big matrix now. 3 by 16 plus 0 by 3. That's this guy here. And to get this guy here, we do the same thing. Row 1 by column 2. This would be 3 by minus 2 plus 0 by 7. Down here now, we have row 2 and column 1. Row 2 in matrix A, column 1 in matrix B. So that would be minus 4 by 16 plus 1 by 3. And then row 2, column 2. Row 2 in matrix A, column 2 in matrix B. That would be minus 4 by minus 2 plus 1 by 7. All right? And we proceed as follows. 16 by 3 is 48. 0 by 3 is 0. 48 plus 0 is 48. 3 by 2 is minus 6. Minus 6 plus 0 is minus 6. Minus 4 by 16, minus 64. Minus 64 plus 3 is minus 61. And minus 4 by minus 2 is plus 8. 1 plus 7 is 7. 8 plus 7 is 15. All right? So again, we go in the corner and we say that AB is equal to what? 48 minus 6 minus 61, 15. And we have that in the record just to verify that AB is not equal to BA. So again, we use the same pair of matrices and we reverse the order this time. So let us go back. Now, I'm going to take the liberty here and go a little faster because I trust that you would have been looking carefully at the video, paying attention to what is going on. And as I always encourage people, it is better if you write along as I work. So as I work, as I talk to the problem, you have a pen and paper and you write it out. That way you get to follow what is going on so that you can then apply it to some other problem, some other problems that you will do to practice afterwards. All right? So we're switching the order now. 16 minus 2, 3, 7, multiplied by 3, 0, minus 4, 1. So what I'm going to do now is just work it the way we would work it, that we say in an exam context, in a context where we're familiar with it. So you now get the opportunity to see what the working would look like when somebody understands the topic. All right? You see what happens when we ride in the bike without the tricycle wheels at the back. Yeah? So generally what we would do, and this is something that I would advise, right? You maintain your notation here for the order of the matrices, right? And you make sure that the number of columns, well in this case in matrix B, is equal to the number of rows in matrix A, right? Remember we're doing BA now, all right? So I'm going to leave out this part here and go straight to the arithmetic so you get a sense of what's going on. All right? So we know, if you want to be sure, just to be sure, you're going out a corner somewhere and you know, well, all right, this is what the answer will look like. All right? Sometimes you need a little guide just to make sure, especially in the early stages. But I will just work out the arithmetic as you see here. So this now is equal to big matrix. 16 by 3 plus 16 by 3 plus minus 2 by minus 4. Minus 2 by minus 4. Alright? Across here now, we have 16 by 0 plus minus 2 by 1. 16 by 0 plus minus 2 by 1. We have 3 by 3 plus 7 by minus 4 down here. 3 by 3 plus 7 by minus 4. And we have 3 by 0 plus 7 by 1. 3 by 0 plus 7 by 1. Alright, that's the matrix. We don't need all that. We just go in here and here. Which means then that we could take some space below here and say that this is equal to what? 48. 60 by 3 is 48 plus 8. Right? So you see in this one, I'm going the extra mile in terms of writing out the products here. Right? 3 by 3 is 9. 9 minus 28. 9 plus minus 28, right? 7 by minus 4 is 28. 60 by 0 is 0. Plus minus 2 is minus 2. 3 by 0 is 0. Plus 7 is 0 plus 7. So that the final answer will be 48 and 8 is 56. 0 minus 2 is minus 2. 9 minus 28 is minus 19. And 0 plus 7 is 7. So that is the matrix BA. Alright? So you see, again, even in the case where the rank, the order, the dimension of the two matrices is the same, that AB is not equal to BA. So just for the record, BA across here, BA is equal to 56 minus 2 minus 19, 7. Alright? Nice. So in general, we know now that for matrix multiplication, generally AB is not equal to BA. In other words, matrix multiplication is not commutative. Matrix addition is commutative. A plus B is equal to B plus A. Matrix subtraction is not commutative. A minus B is not the same as B minus A. In fact, A minus B is minus B minus A. So we have that on the board here. You have that there, you could see it. So I will steal some space just to make a couple brief notes on some other stuff. Alright? So, addition. A plus B is equal to B plus A. So matrix addition is commutative. Matrix subtraction, however, is not. A minus B is not equal to B minus A. On the contrary, I could steal some space here now. On the contrary, A minus B is actually equal to minus B minus A. Alright? So we could put this in one box, put that in another box. Alright? This is just like general subtraction. 7 minus 2 is 5. 2 minus 7 is minus 5. Right? When you're minus and you're switching switch the place of the numbers, the sign will change. Alright, so that is basically it. So I want to do one last example now. And this is a very common example. This is something, as I tell my students all the time, if it's one combination you need to know, absolutely need to know where the multiplication of matrices is concerned, is this particular combo we're going to do now. And the reason for that is simply that this combo shows up anytime you have to do, you know, sometimes they will give you a pair of simultaneous equations and they will tell you use a matrix method to solve this pair of simultaneous equations. Now, if you get a pair of simultaneous equations in number 10 in your CSEC mathematics paper. 99 times out of 100, they will be expecting you to use a matrix method. All right? They may, I highly doubt it, but you never know. They might actually give you the option of doing something else. So for example, they might say, using a matrix method or otherwise. I highly doubt it. But what I can tell you is that unless they give a very clear instruction that you are free to not use the matrix method in number 10, my humble suggestion is to use the matrix method. So if they just give you a pair of simultaneous equations and say, solve this pair of simultaneous equations in number 10 in your CSEC, right? Do not go looking to do elimination and looking to do substitution. In other words, in the absence of a clear instruction that gives you the option to use the traditional methods to solve simultaneous equations, if you find yourself having to solve a pair of simultaneous equations in question 10 in your CSEC mathematics paper, tell yourself that they're looking to see you use a matrix method. All right? So for example, and you will see this in the subsequent videos, and I guess whenever we do some live questions on the subject, they might give you a pair of simultaneous, no, they will give you a matrix A and tell you find the inverse of the matrix A, and then having found the matrix, having found the inverse of the matrix, which you will see in subsequent videos to this one, they will then say, hence, solve the pair of simultaneous equations. So in other words, they didn't explicitly say using a matrix method, but the very fact that they invited you to find the inverse of a particular matrix, and then they say hence, the word hence there suggests that there's a link, a connection between the working for part A and the answer you get, sorry, the working for part B and the answer you get for part A, or the working for part C and the answer you get for part B, etc., etc., etc. All right? So you had to look out for these things, you had to look out for these little nuances in the questions, and this is where doing past papers comes in handy, because you get a sense of the language that the examiners use, you get a sense of how they say stuff, how they put things across, so that you're not really in any doubt then as to what their actual intention is in the question. Good? All right. So I will purposely construct a totally random, in fact, no, forget that. Let me just do the regular matrices, and we will do that. That thing that I have in mind, we will do that at a later date. All right, when we actually have our live session or live sessions where we're discussing matrices. Yes? All right, so the particular combo that I was referring to is this particular combo, where you have, let me say, 3 minus 2, minus 5, 7. You have a 2 by 2 matrix multiplied by a 2 by 1 for, no, let me choose another number now. 6 and 1, 2, 3, 4. Minus 4. Alright? This is a very important combo to be aware of when you multiply matrices. So let me say this is a 2 by 2, right? 2 by 2, and this obviously is a 2 by 1. All right? 2 rows, 2 columns, 2 rows, 1 column. All right? And just as we did before, we verify that the number of columns in matrix A is equal to the number of columns in, the number of rows in matrix B. Once we verify that, then we could see that the answer we will get will be a 2 by 1 matrix. Nice? So in other words, 2 by 1, it will look something like this. The form, the appearance of the answer will look something like this. Right? 2 rows, 1 column. Nice. So with that in mind, we can now do the arithmetic. So I'm going to move this here now. I'm going to put this down in the corner here, right? Generally speaking, in an exam, you'll want to go in a little corner, the little working column that we are accustomed, the working column that we were taught to use in primary school. The principle generally is that you take some space somewhere on the side, you write up your stuff, and then you come back in the question. So in doing the arithmetic here, what we end up with would be, remember this is what it looked like, right? Row 1, row 2, 1 column. So the first row from this matrix A and the one and only column from matrix B will be interacting to give you the element at the intersection of the first row and the first column in the answer, the matrix C. Good? So what you'll have will be this row multiplied by this column. So you'll have 3 by 6 plus minus 2 by minus 4. All right, you put the answer in black now. All right, so on top here you will have 3 by 6 plus minus 2 by minus 4. And then, of course, in the bottom here, the location of this entity is the intersection of the second row and the first and only column. Second row in matrix A, first and only column in matrix B. So you'll then have minus 5 by 6 plus 7 by minus 4. All right? Which would then be, you'll get what? 18 plus 8 minus 4 by minus 2 is plus 8 on top. And on the bottom, you'll have minus 30 plus minus 28, which would be minus 30 minus 28. And then, of course, your final answer would be 18 and 28. 18 and 8 is still 26. Minus 30 minus 28 is minus 58. All right? So that's the answer, 2 by 1. So this particular combo, 2 by 2 by a 2 by 1, very, very, very important. So if you want to be absolutely strategic, my suggestion will be to work a few of these to make sure you get this particular rhythm, because you will need it when you have to solve a pair of simultaneous equations using a matrix method. Of course, we could go on and on and on with other combos of matrices. All right, we could do a 3 by 2 by a 2 by 1 and whatever, right? So at this point, I will round off this particular video, right? I would have given a particular series of general basic concepts, and the invitation for you now at this point is to, in fact, no, let me work out one last one, just for the record, right? Let me choose some big numbers, because the syllabus did say that, let me read the thing exactly, hold on. They did say that and I quote, hold on. I have the syllabus here. Right, they say problems involving determinants are restricted to 2 by 2 matrices, right? So where the square matrices are concerned, you're going up to 2 by 2. Matrices of order greater than m by n will not be set where m is less than or equal to 4 and n is less than or equal to 4. So in other words, the biggest matrix you could get in a CSEC would be a 4 by 4 matrix. You wouldn't get a 4 by 4 matrix to find the determinants or a 3 by 3 matrix to find the determinant. But you might get a 4 by 4 as part of a multiplication. You might get a 3 by 3 as part of a multiplication. So here we will do. We will use those big numbers in one last example just to demonstrate the multiplication, and after that, boom, we cap off this video, and then the challenge is yours to find questions and work. Right? I will supply questions in the website with this video. Don't limit yourself to my questions. You have textbooks, you have the internet, etc., etc., etc. All right, so this is the stage now where you have to go and get it. Make sure and get it, so that when you go in the exam, you don't have the problem of not being able to multiply 2 matrices. All right, so let me finish. Last rounds. All right, so they say nothing bigger than 4. Well, let me go on the end now. Let me go on the line. So suppose we have a 4 by 2 matrix. Hey. A 4 by 2? Yeah, why not? We can have a 4 by 2. 4 rows and 2 columns, right? 4 rows, 2 columns. So 3 minus 6, 4, 1. 0, 5, 9 minus 8. All right, a 4 by 2 multiplied by a 2 by 3. 2 rows, 3 columns. 6, 0 minus 1. 4, 8 minus 7 minus 3, 2, 1. 2 by 3. What are we doing with this? Right? We don't need this column here. Right. So we have a pair of big matrices. So we have here a 4 by 2, 4 rows, 4 by 2 multiplied by 2 rows by 3 columns. All right. Make sure you can see that that is a 4. The number of columns in matrix A is equal to the number of rows in matrix B. We check that out here. So the answer will be, watch it, a 4 by 3 matrix. That's what we're dealing with. And I work in this just for the sake of explanation, just for the sake of illustration. You want to be able to do this if push comes to shove in a number 10. Yeah? So, we know that the answer is a 4 by 3, which is to say that, let me steal some space in the corner here. 4 by 3 is 4 rows and 3 columns. 4 rows and 3 columns. All right? Yeah, that is what the answer look like. Row 1, row 2, row 3, row 4, column 1, column 2, column 3. Right? We're working at a big example here now, so you can see the thing in action at the outer limits of what CXC will be willing to give you. Good? So, we go in. So, first row interact with the first column here. First row, first column here. Second row, first column. No. Generally speaking, I like to work my matrices, follow the rows first and go down. I am sure there are people who would follow the columns first and go across. Doesn't really matter. All right? So I will do it how I accustomed to it. If you prefer to follow the columns first, the choice is yours. Right? I don't pressure my students. As a general rule, I don't pressure my students to do the thing how I would do it. All I ask of my students is that they take their time and they work the arithmetic properly. That way you will get the same answer that I get, provided of course that both of us do whatever we're doing correctly. Good? So, first row, first column, boom. First row, second column, boom. First row, third column, boom. Second row, first column, boom. Second row, second column, boom. Second row, third column, boom. Etc., etc., etc. Nice? So we fill in the blanks now. Alright? So we know what the thing would look like. So first row by first column, that would be 3 by 6 plus minus 6 by 4. I had to go real small with the handwriting here, but hold on. I have to go chunky. Yeah, so we go in. 3 by 6 plus minus 6 by 4. 3 by 6 plus minus 6 by 4. 3 by 0 plus minus 6 by 8. 3 by 0 plus minus 6 by 8. And 3 by minus 1 plus, make sure you can see the minus sign here. 3 by minus 1 plus minus 6 by minus 7. Alright? So 3 by minus 1 plus minus 6 by minus 7. So we're going down now. Alright? 4 by 6 plus 1 by 4. 4 by 6 plus 1 by 4. 4 by 0. In fact, no. Let me fill out a column first, just for the sake of illustration. Right? This guy here, third row, first column. This is what we're looking for here. Third row, first column. Third row here, first column here. Right? So it would be 0 by 6 plus 5. I'll be so careful with this space here. Plus 5 by 8. And then we finish. We come down here again. Fourth row, first column. Fourth row, first column. 9 by 6 plus minus 8 by 4. 9 by 6 plus minus 8. Woo. Plus minus 8. Hold on. 9 by 6 plus minus 8 by 4. All right. That's the first column. So some people will fill out this first and then go across. My personal preference is to fill out here and go down. Either way, same difference. Alright? Right, so now we could continue. So this guy here will be second row, second column. Second row, second column. So that will be 4 by 0 plus 1 plus 1 by 8. And then over here will be second row, third column. Second row, third column. So it will be 4 by minus 1 plus 1 by minus 7. We're coming down here now. Third row, second column. Third row, second column. 0 by 0 plus 5 by 8. Right? Third row, third column. Third row, third column. 0 by minus 1 plus 5 by minus 7. Fourth row, second column. Fourth row here, second column here. Alright? So that will be 9 by 0 plus, hold on, I need to take my time and write this thing. 9 by 6 by, I'm trying to be so meticulous here. 9 by 6 plus, what it was? 9 by 6 plus 0 by 6. 0 by 6 plus 5 by 4. I get 8 here. 5 by 4. See the kind of craziness we had to avoid? Right? 9 by 6 plus minus 8 by 4. Alright? 9 by 0 plus minus 8 by 8. 9 by 0 plus minus 8 by 8. And 9 by minus 1 plus minus 8 by minus 7. 9 by minus 1 plus minus 8 by minus 7. So that there is the overall matrix that we will get as the answer. So we put the little curly brackets, right? I doubt very much that CSEC could bring something like this, but it's in the syllabus. So once it is mentioned in the syllabus, the best thing to do would just be to prepare for it. You don't want to be caught flat-footed because you didn't think they would do it, and then boom, they actually do it. And then they will say, well, it's in the syllabus. Yeah? Right. So we just finished the maths now. 18, 6 is 18, 18 plus minus 24. 18 minus 24. 24 plus 4 is 24 plus 4. 0 plus 20. 0 plus 20. 54 minus 32 is 54 minus 32. We do how to calculate that here. Right? 9 6 is 54. 8 4 is 32. 0 minus 48. 0 minus 48. 0 plus 8. 0 plus 8. 0 plus 40. 0 plus 40. 0 minus 64. 0 minus 64. Minus 3 plus 42. Minus 3 plus 42. Minus 4. Minus 7. 0 minus 35. 0 minus 35. Minus 9 plus 56. Alright? That's the matrix here. So your final answer, ladies and gentlemen, is 80 minus 24 is minus 6. 0 minus 48 is minus 48. Minus 3 plus 42 is 39. 24 plus 4 is 28. 0 plus 8, no. 28 back up here. Alright? 0 plus 8 is 8. Minus 4 minus 7 is minus 11. 0 plus 20 is 20. Alright? 0 plus 40 is 40. 0 minus 35 is minus 35. 54 minus 32 is 22. Yeah, come now, man. Better than that. 22. 0 minus 64 is minus 64. And minus 9 plus 56 is 47. Alright? Right, so 22. So that there is the final answer. Right, so as you see, even with the big board, 22 minus 64, 47. 22. Yeah? Look. 22 minus 64, 47. So even with the big board, you see how we struggle for space once the dimensions get kind of big. You had a 4 here and a 3 here. So for that reason, and particularly given the new format in which they have the exams, where they actually give you an exam sheet and you have a particular space to write the answer, I doubt very much that CSEC will give something like that in multiple choice. They might give you the multiplication with missing pieces to fill out or something like that, where you don't have to write all of this in an exam paper. Alright? But we work it out here still, just for the record. And of course, my advice to you is to find some of the ones with big ranks. Right? You could go up to 4 if you want. You don't have to do any work involving a 5 by 6 multiplied by a 6 by 7. Nah, you gotta go through all that. You don't have to prove anything to anybody. Once you're okay with these things, then we know that if you have a 12 by 11 to multiply by 11 by 13, then you could do it. In that case, you could use the calculator with a clear conscience, or the computer, or whatever it is. So, this brings us to the end of this particular series of videos. This series of videos having dealt with the topic of matrix multiplication. Alright, the video series may have been a little longer than you would have liked. You know, people can't concentrate on anything for more than 5 minutes these days. But for me, in terms of how I do what I do, I like to go the extra mile in terms of explaining stuff, in terms of talking about it, in terms of demonstrating it. It's just for me, and that is why I have been using the technology since 2015 to record lectures, to record myself explaining stuff. So that way I don't have to go through this repeatedly. Alright? Anytime somebody come to me and they say, well, sir, I don't understand how to multiply matrices, all I have to do is say, hey, watch the video. At that point now, you are the student. You have to take your time and listen. Remove the distractions. Whatever the distraction might be, whether it's food or company or the phone or the TV or whatever it is, you cannot watch these videos while you're distracted. You do that, you wouldn't be making the best use of the time, and you would spend the time and still not get the full benefit of what information is contained in the videos. You skip through the videos because you find it too long. Or in the very worst case scenario, you just ignore it altogether. Well, at that point, as I tell my students, if you're doing that, then you better make sure that you know what you're doing and that you get the information from another source. Right? If that's the case, then I can argue with that. Right? So, I hope and I trust and I believe that the video will be of benefit. The next step now is to go on and do some questions. You can start with the textbook. You can start with the questions accompanying the video here on the website. And of course, you will raise the level to actual past paper questions. Preferably from an array of different examining bodies. CSEC, CAPE, you have the West African exam, you have the Australian exam, Singapore exam, you have some US exams, right? Anywhere that's speaking English, you can do it, and you never know. You might get a matrix question in Spanish, and even though you mightn't understand all the words, by looking at how the question runs, you could get a sense of what the question is and do it, right? So in other words, don't limit yourself. Don't limit yourself. And as a general mentality, I want you to take into anything that you're doing. All right? So, keep good, take care, and as always, we have plenty more where this is coming from. Boom!